Alright, so I woke up this morning and I made the mistake of deciding that I wanted to implement a TCP proxy in BTD6 for the co-op functionality so that I can intercept and manipulate co-op messages as I so choose. I thought this would only take a few hours and not like literally all day, just to even get the framework set up so that I could do this. Yeah, I was wrong. So in wanting to do this, I guess the first step was actually firing up BTD6, leveling myself up legitimately or not. We'll leave that up to interpretation, to level 21. Hopping on co-op, and so I can connect. And then once I've done that, what I can actually do is I can open Resource Monitor on Windows and look at active TCP connections based on process. And so if we look, we see a bunch of BTD6 process TCP connections, and so there's a bunch to 888, which that's because it's hitting my Fiddler HTTP/HTTPS proxy for those things. But then we notice this strange one where it's hitting that's an AWS IP range on port 1445, which is not like a common protocol. So what I then did with this, okay, hold on, I gotta not screw my buddy over here too much. Yeah, he'll level himself up, I don't have to play. I decided to hop on my router and using the tcpdump command with some flags, so like w some co-op.pcap -host, whatever that IP was from here, and then specify my interface, which is like bridge LAN, I think. So I recorded those packets being sent and forth between my host and the BTD6 server. And if something you'll notice is each time you connect to a BTD6 server, the remote address is not always the same. In fact, there's quite a few that it can be. And so actually examining the communication, this is the recording I took on my router of what was being sent to and from my computer in the BTD6 co-op server. We see a lot of like filler looking things. We see these strings, so it's clear that this isn't compressed or encrypted, which for us means, wow, once we get the TCP proxy up, we should start being able to actually affect things in game with some amount of swing. Especially, I mean, we've got like cell action, tower simulation, ID input, blah blah blah, some bytes that hopefully we'll figure out what those mean later. Might be a bit of a process. But yeah, so it's very clear that if we could intercept and manipulate these programmatically or on the fly, we could potentially do some very interesting things in co-op. So the question of how do you actually do that is where things start to get complicated. So obviously you're going to need some sort of server service that can bridge that connection for you and allow you to read and write to it. So I wrote this, and essentially what it does is it creates a socket server on a port, and anything that's written to that socket, it actually has a child socket, which is the socket to the actual Ninja Kiwi server, and it just writes back from one to the other, and we've got this middle area where implement automatic changes. So if we want to make manipulations, we can do it right here or right here. So the question is, how do we get the game to actually hook up to that and connect to that instead of the server it wants to? And so in some cases it could be a matter of, okay, we just need to overwrite some of the game code to point to that server instead. However, the process by which the game actually finds a server is more complicated than that. So it actually makes an HTTP request, well, an HTTPS request, but it's HTTP based, to the matchmaking server API, which is good because some games will do it where it actually hits it on a separate socket, and then that would just be a pain. So what I have set up basically, I'll see if I can. I have this rule in Fiddler, which these are the two endpoints that I found using Fiddler when you actually attempt to join a game. Join and create. So join will throw you in a game that exists if it can find one, or create will make a new one. And so I have it redirecting to something listening on my own network. So if you notice, that's two different ports. I wrote an application that what it does, and I'll see if I can get an image. Let's see, matchmaking. Here we go. Here's a legitimate matchmaking create request. And I'll see if I can get a screenshot of that. Oops. So what it does is it takes that request, and instead of making it to the actual API server, it makes it to my middleman. And what my middleman allows for, this slash create, and you see, oh no, ELB cookie, and here's the body that it sends to the server. I wrote a bit of software. Oh shit, balloons are leaking. I'll just give them all my money. Yeah. So yeah, I wrote a bit of software called BTD6 game proxy. So this isn't like the TCP proxy. This is for the actual thing where it tries to find you a game server to connect to. And so a response from this, hold on, I'll see about screenshotting the JSON. Oh, it does not want to format that pretty. Essentially, as part of that response, oops, it has the relay IP in there, port, region, a few other things as well. And so that's neat. That's very neat. And if we can proxy that request, instead of returning the actual IP that it wants you to connect to for the game server, we can fill in our own, which is what this code does here. And so right now I only have it doing for creating servers, because that's how I've been testing it, because it's more reliable and consistent in how the data is shaped that you actually get back from the API server for matchmaking. But what my code does is it grabs the old IP, grabs the old port, it makes a request with those to that other application, this right here, which then creates a new listener, and then replaces those in the JSON, the relay IP and relay server that get sent to the game that the game actually reads, reserializes them, and sends the request back. So the game never knows that it isn't making a request to the real API server, and it's actually being sent to my server, which makes a request on its behalf, modifies it, and then sends it back. So it's a very cool implementation of a man in the middle, and I got around all of the like SSL issues just by, I'm using Fiddler to orchestrate this, and I have Fiddler already trusted with a root certificate on my machine. And so I don't even have to worry about the fact that, yeah, this is actually an HTTP-based solution I have right here. I didn't bother doing SSL for this. And I'm able to man in the middle and modify these requests. Now the thing with this is, if we look at the response, there's actually a signature field. So this right here validates the data. And if the data is changed, this should validate it. So what is this? Does this matter? So the first thing I tried was to send some data back. I'm not going to be able to show it because of what I ultimately ended up doing. But if you do send it back with if you modify the data and the signature is no longer good, when the game receives it on the matchmaking menu, it'll just say, yeah, bad signature, what happened here? It gets a little pop-up in it. You can't connect, it's bad. So question number one is, what the hell format is this signature? And is it something that we can implement in this code to be able to re-sign itself after modifying it? So enter a lot of stuff. So Ghidra. So this is a reverse engineering tool that I've used IL to CPP's Ghidra export to actually rename a bunch of the functions so that we can see what they actually are. And thanks to some of the help from, I think Bow Down pointed out that they use HMAX SHA-1 for, they do a similar implementation to this for DG data. The function that does it's actually different, but it's under the hood using some of the same helpers. And so my first thought on this was SHA-1. I was really hoping it was straight SHA-1. I did try a few tests of different formats with just straight SHA-1. No cigar, no luck. So yeah, that didn't end up working out at all. But HMAC SHA-1, that's good news, because if it was asymmetric, we might be fucked. But HMAC SHA-1 means basically, if we look at this function right here, yes, I'll pull it up in, so these are actually string pointers. If we look from the dump.cs made by il2cpp, what's the name of the function? Hex HMAC SHA-1, here we go. It takes two strings, which means a key and an input. So if we want that key and input, we can actually use a debugger, enter x64 debug. So we can attach to BTD6. I really hope this doesn't fucking dox me, holy shit. BTD6, attach, and we can then, hold on, it breaks a bit on that shit, okay. I've got some existing breakpoint, I guess I'll disable it. Essentially what we can do is we can look at symbols, we can look at the base of game assembly, we can copy that, and then we can take it into Ghidra, and Ghidra has a memory map where we can then hit this button, paste it there, which I've already done, hit OK, and rebase everything on it, which means when we look at this function, if I want the address of where the function actually is in memory during execution, I can literally just copy this, whoops, copy that, open x64 debug, go back to the CPU view, go there, and just set a breakpoint. And so I'm not going to do that, but then we can then do something that would trigger it. So like, wow, how is this game still going, and how is it only around 13? I'm gone. Rip that guy. So what we would do in this scenario, leaving the game would trigger it. Oh shit, wait, fuck. Oh, I'm still attached. Okay. And so then in our RCX and RDX, we would have pointers to the two strings that we were interested in. From here, we would have a pointer to the key and a pointer to the input, and it would just be a matter of just right-clicking them, follow and dump, and changing the view to ASCII, and we could literally just see the key. So I did that. I did pull the key. I don't have it on me right now. I did save it somewhere. I did see what it was counting as the thing. I tried implementing it. I don't know if I got the encoding right. I just was not having any luck getting it to work properly and actually give me back the signature I wanted without modifying it, getting back the signature that it shipped with. So I don't know what that was. So what Bowdown pointed out was that historically for SKU mods, they just patch out the function that actually verifies things. That's not the same function, so that patch wouldn't work. And I wanted to avoid patching if possible, but I just got so tired of this shit that I decided, fuck it, I'm gonna patch. So what I actually did was break on a different function, because this one wasn't actually triggering when I thought it would. I ended up breaking on hex, no, it was hex hash. This was it. And so I can show that, I guess. I can take this address, can go there, okay, I can toggle a breakpoint, and then I can do something that would make a request that would check. And boom, I already hit one just by trying to open that. It tried to make an API request. And so now I can look at things, I can be sad, but what I'm interested in is the call stack. And if I try to move up the call stack, and follow to, follow from, whatever, if I look up and subtract based on the offset that things loaded in at, I can, I can start, hold on, whoops, where's the call stack? So I can take one of these addresses, copy from, is that the right one? Who knows? And then I can pop open Ghidra, and I can, there's some way to go to. And then I can paste in that address. and I can see, you know, it's calling hash utilities, blah, blah, blah. There was one of them, I went far enough up in the stack, and I saw it was calling a, ooh, the real Steven cipher. That's interesting. I've not looked at that. Okay, anyway, whoa, okay. I forget what it's called now. Here we go, transfer authority, that's what it's called. There's a validate function, and if we look at what validate actually is in the dump, what's it called? Oh, authority. Here we go. If we look at validate, it's a Boolean, and based on that, we're guessing if we just patch this to return 1, which I've already done to my binary, all of the signature checks will pass. And I did that live actually first before I edited the game. I just pulled the address from Gidra, rebased on that. If I go, whoops, here, validate, yes, take me there, yes, go. Cool, I'm here. If I grab this address, whoops, and I pop back to x64 debug, I'm going to kill the old breakpoint, and if we actually go here, look at the memory, look at the instructions. So here I did modify it, but what I did was I changed the instructions before I actually patched the binary to test if it would even work. So it just moves 1 into the AL register and returns, so it just thinks it always works, and that everything's always valid. So having done that, when I actually attempt to connect to this, and actually I'm gonna comment out those. This shouldn't mod the data. Okay, here we go. This is a good example of it working. So now when I do this, and I'm gonna have to turn Fiddler on so that it actually uses the redirects, the autoresponder enabled. Cool. I can pop back to here, and now if I go to create match, 2-player, this, medium, standard. Oh shit, it's trying to hit. Shit, wait, what's it doing? Oh, the debugger. Oh, yeah. Okay, I need to detach the debugger now because it'll hit exceptions on this shit. There we go. And now I am in a sandbox mode Monkey Meadow map. So I don't actually have anybody to play with because I don't have any friends. I might do a game later and upload it. Might even be uploaded before this if I edit and upload this, if I edit this, if I upload this, who knows. So it might just be internal notes for me. But I now have a sandbox mode, and it gets better, so I can actually edit more things. And now that there's no validator bitching me out when things are not as it would like it to be, I can enable this. And what this does is, the button, boom, moon landing. What map did I select? Why? Can I even pick moon landing? Moon landing, locked. Actually, though, moon landing. And so yeah, I can obviously intercept and change other things related to the match creation, and I've not tested the full limits of this yet, and this wasn't even the purpose of this, but it was still pretty cool. So here's where it gets interesting. Now that I have control over matchmaking things like this, and I'm going to re-enable my old stuff, I can pull out the IP and the port that it wants me to connect the match, or not, for the actual gameplay server on. And I can then make a call. I'm not using RPC, I'm using a RESTful API to another local service I have running. And so this needs to be running for this to work. But this is essentially what it is it's just a web interface that just grabs an IP and a port, an address and a port, and it makes my TCP proxy connect to the what it was originally going to connect to and start listening. And so if I fire this up and I fire this up, so this is actually listening on 2 ports because I was lazy in my implementation of this and I wanted an easy way to do it so that I could hit both join and create. Join uses 1 port, create users are different, and then this is the actual TCP proxy. So I have both of these running. Fiddler's on, so when I actually create this, here we go. I can hit public, and if we look at this, this is the messages. It's very similar to what we saw in that Wireshark dump. But now I have like live ability to edit it in my script once I implement that and start trying to break down specific messages and figure out what do the bits mean. And so, you know, some players have bad connections, and I guess it's shitting the bed right now. But I can place towers, and you can kind of see something happening. I can send a thing, and you can see that showed up there. And I'm really curious about if we can get like arbitrary code execution on other people's boxes with that. That'd be scary. And so, you know, I can start the game. And so, yeah, basically, if I modify my TCP proxy, because right now all it's doing is just spitting out into standard out what's going down, and I can live watch my game happen, just the raw TCP communication. But in a more perfect world, I can now start breaking down and, oh damn, I don't know how this map works. What the fuck, man? I can start breaking down and analyzing what's actually going on. Wait, did the dude leave? Oh, yeah. Well, fuck me, man. Let's see, cool. Alright, so I actually need to restart these, and I'll try again. See if I actually, whoops, wrong shit. See if I actually get a dude. Whoops, not quick match. Let's go for 3-player. It's kind of less likely to get fucked. And then boom, you see it hooking up again. And you see, oh, a guy rolled up, and you get to see all these stats for him too. It's all super transparent. And so, I mean, all of these things I can modify what gets sent back to my client. I can modify what gets sent to the server. I see these referred to as a relay, so I'm afraid that I might be sending messages directly to the other guy, in which case I might be able to do malicious things to other people's BTD6 clients. I don't know. This will enable me to start being able to research that. But yeah, so this process of actually being able to get it connected to my own custom TCP proxy took so fucking long, man. Just, I mean, I went through so many components of it, even getting the Gidra set up, running the IL to tcpdump. I didn't cover any of that. And then actually running the script that brings in the names, and then knowing how to use those. And then I didn't even show patching the binary. I didn't show a lot of the fiddler fuckery and what a good request looks like. Actually, I'm going to disable fiddler. I'm going to leave. I should hopefully take out my socket. Oh. Is it? Well, I might have crashed the game. That might be a good spot to leave, honestly. I think I showed off what I meant to. Hopefully I can do some cool shit with this. But yeah, if you ever think you're just gonna, you know, implement a TCP proxy for BTD6, it's just as easy as patching a string in the binary, bro. No, not at all. I've got all these components set up. It's a bitch. I could have done it another way. I could have used DNS. I thought about doing that. I wouldn't have had to modify the signature checker to not be angry, because I could actually, I'm not running DNS. That's too much work. It's way too much work. This way is hacky, but it works. If you have no idea what a TCP proxy is or the value of it and how I can live edit the messages sent between me and the server, yeah, I'm sorry. Hopefully I'll be able to do some videos that show the value of that. But yeah, that's what I've got today, so thanks.